Alrighty, hello everyone. I thought I would make a video going through the VCAA questions on IR so that you can come and have a look back at this if you need it for revision at some other point or you're stuck on any of the questions. So I'm going to go through the basically all of the VCAA questions for the last 4 years, as well as some from the Northern Hemisphere exams. So a few of the questions I won't be able to put in here just because we haven't covered NMR or mass spec yet, but they'll show up later when we're able to combine our knowledge of techniques together to identify molecules a bit better. You'll see that here most of the questions have to be multiple choice just because without NMR or mass spec, we can really only just narrow down what type of molecule it is, not what exactly molecule we're looking at. So we've got a question from the 2021 exam. So we've got an IR spectrum of an organic compound, obviously, and we can immediately basically chop off everything that's below 1500, and we can say, okay, not going to look at that, don't really care about it. And if we look at what's on the left here, there's only really three things that we can see. We can see a peak here, and a peak here. Now, hopefully, by this stage, you should remember what's the first thing you should be looking for? You should be looking for 1700. Look if there's that carbon-oxygen double bond. This definitely looks like a carbon-oxygen double bond. Now, if things are looking a bit iffy, you can try and compare it to see whether there's a carbon-carbon double bond. But that's generally rarer than just having a carbon-oxygen double bond. Next up, we've got this kind of shallow one here. You can see that the only reason it's this far down is because it's building off the back of this really broad one. So we've got this one here, and we can say that this is a carbon-hydrogen bond pretty nicely. And the last one here is we can say this is either an oxygen-hydrogen or a nitrogen-hydrogen here. So we're going to have to use this information here. We know it has a CH, not really useful. Everything down here already has a CH in it. But we do know it has a C double bond O, and we know that it has either an OH or an NH bond. So let's have a look at what our answers are down here. Note that they're basically all going to have to be different types of molecule, because if they were the same type of molecule, we wouldn't be able to tell the difference between them. So one at the top, we've got an ester. Now we draw out an ester group. You can see we've got a carbon to oxygen bond. So we could probably, if we looked at it really hard, we could probably try and find one of these peaks that was carbon oxygen, but it's a bit hard because there's so much stuff in there. So we'll just kind of ignore that. Okay, there is a carbon oxygen bond, a double bond, which we can see in the spectrum, but we see that there's no OH or NH. So this one has to be out. Next one here, we have an aldehyde. So it's that carbon oxygen double bond on the end. Okay, so we've got that carbon oxygen double bond, but once again, there's no OH or NH bond. So this one has to be out as well. Next, we've got this amide and amine. So an amine at one end and an amide on the other end. It's going to look like this. So we've got a C double bond O and an N single bond to an H. So this one is looking reasonable for a potential answer. And the one down the bottom, we've got an NH. So an amine at this end, NH. We've got a CO at this end. So note that that's not a carbon oxygen double bond. This isn't a ketone, otherwise there wouldn't be an H here. This is just CH and then an OH. So if I was writing this, I would probably just put a bracket around that to make it really clear what was happening there. It's actually an alcohol and an amine. Now we've got an OH or an NH, but there's no C double bond O in this one here. So this one has to be out of the question. So it has to be this one here. And hopefully you can see here that it's kind of difficult to tell the OH and the NH apart. We're going to see that in the examiner's reports that they're pretty similar. And they're basically, VCAA's not going to expect you to tell the difference between them. All right, here we've been given a molecular formula. Make sure you look at whether it's molecular or empirical, because that does make a big difference. All right, once again, let's cut it off at 1500. All right, the compound is non-cyclic. Okay, well, basically everything we're looking at is non-cyclic and contains a double bond, which we can kind of see from here. There's something here. Either it's a double bond of C double bond to O or C double bond to C. we look up here. Or well, let's just look at the question first. What does the region basically here and upwards indicate about the bonds in C4H8O? All right, so we can say that there's no OH bond because there's no peak at around 32 to 3500 or something like that. So basically there's no peak here and therefore there's no OH bond. You'll see that a lot of the IR ones are this kind of question of just saying, doing something first and then figuring out the compound later. All right. All right, so let's move on to the next question. So this one here, we've actually been told a bit of information. We've been told that there's a carbon, hydrogen, and oxygen in it, or it consists of all three of these. And so we can look at the spectrum here. So we need to identify the functional groups for the absorption peaks labeled A and B in the IR spectrum. So hopefully you can tell these by this point. Let's have a look at B first. So B is obviously at that 1700 range. We're looking at a carbon oxygen double bond. So B, you would just go C and the equal sign O. A, normally we could say, okay, maybe it's an NH stretch. Because we've been explicitly told that if there's O in it and there's no N, this is going to have to be an OH stretch. Note that for the functional group, you don't really need to specify that it's an acid or whether it's an alcohol. The functional group is just that it's OH. There's no way you could write acid or alcohol in this tiny little thing here either. So A is OH and B is going to be the C double bond O. Next one. All right, so we've got another one here. In the table below, write the bond responsible for the wave numbers given. We've also been told that this one here contains carbon, nitrogen, and hydrogen. So we only have to look at the two peaks up the top. So the one at 2956, the only thing that fits in there is the carbon-hydrogen bond. This one's really, really strong for some reason. I don't know why. They've obviously got an interesting spectrum there. But basically carbon hydrogen is the only thing it could be. So even though it looks weird, just go with your instincts there. You can see that this is going to be carbon hydrogen just because there's not really any other options it could be. Let's put carbon hydrogen in there. At 3376, this one's really weak. Basically, once again, it could be said to be an NH or a C or an OH, except for the fact that we've been told that the only three elements in the compound are carbon, nitrogen, hydrogen. So therefore, the only option it could be is nitrogen, hydrogen, because there's no oxygen. It would be a lot tricky if they said carbon, nitrogen, hydrogen, and oxygen. All right, here's another one here. All right, so immediately gonna ignore everything there. So, okay, what's this one? Probably carbon, oxygen, double bond. Look up here, and we've got probably an alcohol one. It's not particularly broad. So we've got some different options here. So let's go from the top. Aldehyde. Remember, an aldehyde has that double bond, but it has nothing up here. So aldehyde is out altogether. Alcohol is it has the OH, which would be that, but it doesn't have a carbon-oxygen double bond, so that one's out. Amide, which is this one here. We've got the carbon-oxygen double bond and the NH, so that could be reasonable. That could be an NH. And then we've got an ester. Esters don't have any oxygen-hydrogen bonds, so ester's out of the question. It's going to be an amide. One thing to note here, as the this is what the examiner's report says. It says the key peaks are 3300 per centimeter. It could be due to OH, an alcohol one, because it's not super broad, or it could be NH. So note that VCAA, so VCAA is just as confused about as you are about whether you can tell the difference between them just from this data. If you looked at a lot of them, it would be easier to tell the difference, but they're not expecting you to do it. It's somewhat ambiguous as to which one it could be. The 3000 one they say is CH, as we know. 1680 is probably C double bond O. If they said it's an alkene and an alcohol, which is called an enol, not that we really discussed them, theoretically that could be a double bond as well, a CC double bond. Generally, they'll tell you if there's a double bond. All right, and that's it. Just let me know if you've got any more questions or if there's any that you've seen around that you want me to go over. All right, thanks, and I will see you later.